VS Series Defect tool. The defect tool compares the average intensity of small segments to that of neighboring segments and detects areas with an intensity difference that exceed a specified defect level within the inspection region. Detected objects can also be counted and analyzed based on characteristics such as area, center of gravity, roundness, perimeter, and major to minor axis. Connect to the Defect Tool simulator and play through the images. These test images will be used to help explain the main settings of the Defect Tool. Start with image number 2 in the film strip and add the Defect Tool from the Flaw Detection category. Draw the inspection region on the lower part of the target. The contrast view in the image viewer can be used to view areas where it's detecting a change of intensity. The smaller changes are in blue, then it turns to green, yellow, and then red to indicate how much of change in contrast it is detecting. The defect tool will break the inspection region down into many smaller areas called segments. As a default, the segment size is 16, which is a 16 by 16 pixel size. You can adjust that as needed according to the application. We will change that to 8 in this exercise. The shift and compare segment is set automatically, but that can also be set manually if need be. So the defect tool, again, will break that region down into many overlapping segments and take the average intensity in each one of those segments. And it will compare the maximum and minimum intensities of adjacent segments, 4 in each direction, min minus max, to determine if that difference passes a certain threshold, which is the defect level. So the differences are displayed in this contrast view. You can see in this example, there's a lot of noise being detected, and that's due to the hairline features of this target. So what we can do in a case like this is we can change the scan direction. As a default, it's looking for differences in intensity in both directions, but we can set this to only go in the X or Y. So if we set this to just the X direction, you can see we've eliminated almost all of that noise created by the hairline features in that horizontal direction. The gain setting can be optionally enabled, if desired, to help increase the contrast of the detected defects. You can see after we increase the gain, we're getting a little bit of noise in the background, but what we can do is adjust the defect level. So that's the minimum intensity difference considered to be a defect when it's doing the average comparison with the segments. So if we raise that up, in this case, we can raise it to 25, for example. We can get rid of a lot of that noise, and now we are detecting just the defects. With high-speed mode on, the segment size can only be adjusted in increments of 4. If you turn high-speed mode off, you can freely set the segment size as low as 1. For this example, we will leave high-speed mode on and a size of 8. In tool results, you can see the results of the tool. The detected defect level is the biggest amount of change that was detected, intensity change, in the region, and that's indicated by the little crosshair on the screen. And the total defect area is just the overall area of all the detected defective segments. If you want to count the number of defects in the region and analyze these defects with a little more detail, you can turn the grouping function on. What this will do is count the group and count the number of defects that are occurring. So now you get a count, and then as well as other features of the detected objects. When the grouping function is enabled, you can also use the filter settings and filter out any unwanted detections based on any of these criteria. For example, defect area. You can set a lower limit of 10 in this example, and it'll get rid of any small noise that might be occurring. To use any of the other parameter filters, just enable it and set the appropriate limit. Under Label Results, you can view the results and characteristics of all the detected defects. The list can be filtered as desired. The detection order is dictated under the grouping setting. As a default, they are numbered in area descending order. So the largest object is target 0, and then they are incrementing from there. But you can adjust that if need be. Once you have the desired detection conditions set, you can set the judgment limits, which will make the tool pass and fail. You can set a limit on the total defect area, the number of groups, the defect area of the judge label. You can also set a limit on the center of gravity of the judge label if desired. So for this example, we'll set an upper limit of 0 for the number of groups. That way it'll pass if there is no groups detected, and fail if there are groups detected. So you can see image 1 passes and image 2 fails. Now let's add the defect inspection for this upper curved area. So add another defect tool from the flaw detection category. And this time set the region to arc. And then we're going to draw our arc area around the upper portion of the target here. Let's change to the contrast view and view the detections. Now we do need to mask out this bottom area here with the horizontal features. So go back to the region settings and you can add a mask region. Let's add a mask rectangle and mask out the portion that we do not want to detect in this tool. You can see in the upper part of this target, it has some curved features that follow along the circumference that we're picking up on. So we need to eliminate that. So when you're using a ring or arc in the defect tool, you could set the scan direction to either circumference or radius. So radius would scan radially, but we could set this to circumference. So we'll only look for changes in intensity in a circumference direction. So you can see now we've eliminated that those features there. Now we can set up the other detection conditions as needed. In this example, we will set the size down to 4 to pick up on the finer details here. And you can see we are properly detecting our defects and not picking up on that circumferential feature. You can turn on the grouping function if you like to count the defects and get more detail. And then of course, set up the judgment conditions. So again, just like the other tool, we'll set an upper limit of 0 for the groups, and the tool will pass if there are no groups detected, and fail and report back the defects when there are defects detected.